Here we have a SAT math question. There is a system of two linear equations given over here. In the system of equations above, m and n are constants. If the system has infinitely many solutions, what is the value of m over n? Okay, in the given system, each linear equation is in standard form. That is, we have x term and y term on the left side and constant term on the right side. In a linear equation, if you have x term and y term on the left side and constant on the right side, we have to consider the linear equation is in standard form. Okay, now let me consider a system of two linear equations in standard form. That is a1x positive b1y equals to c1, and another linear equation in standard form, that is a2x positive b2y equals to c2. Here we have system of two linear equations in standard form. So if there is if the system has infinitely many solutions, then both the equations must represent the same. That is, the coefficient of x in the first term, the coefficient of x in the second term must be equal, and the coefficient of y in the first equation, coefficient of y in the second equation must be equal, and the constant term in the first equation and constant term in the second equation must be equal if the system of two linear equations here has infinitely many solutions. So that means that both the equations represent the same. Okay, in our problem, the question says a system of two linear equations given over here has infinitely many solutions. So let me write the given system, that is mx negative 6y equals to 10. Let me write the first equation. Okay, if this system has infinitely many solutions, then both the equations must represent the same. That is, a coefficient of x in the first equation, coefficient of x in the second equation must be same, and coefficients of y in both the equations must be same. Constant terms must be same. But here, the constant term in the first equation is 10, but the constant term in the second equation is 5. They are not same. So our first work is to make the constant term same. So because the system given over here has infinitely many solutions, so the coefficients of x must be same, the coefficients of y must be same, and the coefficients of constant terms in both the equations must be same. So for that, what I need to do is I have to multiply both sides of the second equation by 2. So that when I multiply the right side stuff by 2, it will become 10. Okay, now let me multiply the stuff on the left side of the second equation by 2. So when I do so, 2 times 2x will be 4x, and 2 times negative ny will become negative 2ny. And when I multiply this 5 by 2, I'm getting 10. Now the constant term in the first equation, constant term in the second equation are same. So now this system has infinitely many solutions. So both the equations represent must represent the same stuff, and the coefficient of x in the first term, coefficient of x in the second term must be equal. That is, m must be equal to 4, and the coefficient of y in the first equation and coefficient of y in the second equation must be equal. Okay, so now already it has been solved for m in this m over here, but we have to solve for n in this equation so that we'll be able to get the value of m over n. Okay, to solve for n, I divide both sides by negative 2. So negative 2, negative will cancel out. This negative, negative will cancel. 2 goes into 2 1 times, 2 goes into 6 thrice. So we get 3 equals to n. Okay, now I got the value of n, that is 3. According to the question, we have to find the value of m over n. So we can plug in 4 for m and 3 for n. So the value of m over n is 4 over 3. So we find 4 over 3 in option C. The correct answer choice for this question is option C.